Today we're going to talk about sensor redundancy and how not to burn up your components in your circuit. This is pretty important for if you don't want your prototype to catch on fire or you don't want to blow up your Arduino, and anyway, just for, the safety and integrity of your system. Sensors provide feedback on system operation. So they give you an idea of how is your system doing. Is it going to the right spots when it's supposed to? Is anything coming into the way? Sensor redundancy is using multiple sensors to measure the same variable. So maybe if you're trying to measure like how far away something is, you might be using an ultrasonic sensor, and you might put two of them just in case one of them malfunctions. Or let's say you are trying to do a line following thing. So you have an IR sensor that needs to stay over the line. Well, you wouldn't want to just use one, because then if somehow it goes off of the line, then you don't know how to get back to where you were. So in that case, you would use a whole array. So you would have some sensors on the line and some sensors off it, and you would be able to guide your robot back onto the track better. Now, the benefits of sensor redundancy: you get finer control. So the more sensors you have measuring something, then the more accurate you know that your variable is, and fewer accidents in case one of them malfunctions. So an example of this is on a train track. So train starts moving down the track. We need the gate to come down across the road before the train crosses it, so then nobody dies. So if you put sensors that are along the track to measure where the train is, then every time the train hits a sensor, you know that you know where it is. So this is part of an automated system. So once it got close enough, then the gate would come down over the road. Now on something like this, you can see there's one sensor back here, and there's one sensor over here. So those are kind of far apart. You don't actually know where along the track in between these two the train is. And also you can tell how fast it's going between one and the one before it by getting a kind of average velocity from the sensor that passed to the sensor that was before it and divided by the time. But with sensors spaced very far apart, you don't get a super accurate measurement. So you put more sensors, then you can tell, oh, you know a lot more precise location of where it's a train and how fast it's moving. And then if you put them on the other side, then if one of the sensors malfunctions, you know you've still got the second one, so you'll still know where the train is. So you'll want to do the same kind of things in the systems that you build. Now, I'm not saying you need to use 12 sensors instead of 2, but you should look at what is the most important parts of your system to measure, and then make sure that you're using enough sensors where you need to. This is an example of using multiple sensors. So for measuring the speed of the train, then let's say the squiggle curve is actual speed, and then it's almost like a Riemann sum where you're approximating velocity. So depending on how many sensors you have, you're measuring velocity. What you're measuring is an average velocity over a finite time interval. So the shorter that you get that time interval, which is the closer together that the sensors are spaced, the more accurate your measurement is. So it's sort of a way to approximate a continuous signal by using discrete sensors.